Okay, so for those of you that needed to retest on the mid-chapter 9 test, I'm going to go through the problems and work them out. You just write them down on paper. You can either print this attachment and write it as I go, or you can just write it on notebook paper. To turn it in, take a picture of it and attach it to your assignment. Once you do that, you'll be able to retest. When we take our Chapter 9 test, you'll get an additional retest to replace this grade. Okay, so number 1, we see x and x here. So since those are the same side length, that means our angles are the same. So this is a 45, 45, 90 triangle, which means we need to take that hypotenuse and divide by the square root of 2, and then make it rationalize the denominator. So we're going to multiply by the square root of 2 over the square root of 2. So we get 5 times the square root of 2 on top. Square root of 2 times the square root of 2 is 2. Now, we can divide 5 and 2 and we get 2.5. Some people don't like to put decimals with the radical. If you wrote your answer this way, that would be correct, or you could leave your answer this way. Okay, number 2. You got your 60-degree angle here, so that means it's a 30, 60, 90 triangle, because 30 plus 60 plus 90 equals 180. So here's this would be our 30-degree angle. So across from that, the x is our short side. And our hypotenuse, the 24, is 2 times x. So to find the x, we got to divide 24 divided by 2 is 12. And then our y is our long side. So we take our x, which was 12, and we multiply by the square root of 3. Right, number 3, they give us a 45-degree angle. So this is a 45, 45, 90 triangle. Oops, sorry. Which means our 2 legs of the right triangle are the same length. So this side is 3 square root of 2 also. But we want to know x here. So to find x, we have to multiply the side length, which was 3 square root of 2, times the square root of 2. Well, the square root of 2 times the square root of 2 is 4, right? So it's 3 times the square root of 4. But the square root of 4 is 2, so this is really 3 times 2, which is 6. Number 4, we've got another 45-degree triangle. So 45, 45, 90 says our sides are the same, and our hypotenuse is x times the square root of 2. So to find the x, we have to take 16 and divide by the square root of 2, and then rationalize it. So we multiply by the square root of 2 over the square root of 2, and we get 16 square root of 2 on top. Square root of 2 times the square root of 2 is the square root of 4, which is 2. And then we can take our 16 and divide by 2 to get 8 and keep the square root of 2. Number 5, another 45-degree angle here. So we have another 45, 45 triangle, 90 triangle. Y is the same as our other leg, which was going to be 7. Okay, to find the x, that's our hypotenuse, so we have to take the side length and multiply by the square root of 2. Number 6, we have a 45-degree triangle again. So both of our legs are the same length. Our hypotenuse is 12 square root of 6. So to find the leg, we have to divide by the square root of 2. So we get 12, and we can divide those square roots. 6 divided by 2 is 3. and 3 cannot simplify, so our radical is already simplified, and that's our answer. Okay, as you're doing these corrections, make sure you're writing the work and not just the answer. Everything I write, you write. Okay, we have a 60-degree angle here, which tells us this other angle is 30 degrees because we have a 90-degree triangle, or right triangle, which means this 6 is our short side and x is the long side. So we have to take our short side and multiply by the square root of 3 for our long side. Okay, number 8, 30. That tells us it's a 30, 60, 90 triangle, and our y is the short side. So to find the short side, we know the hypotenuse. The hypotenuse is 2x, right? So we have to take our hypotenuse and divide by 2 to find our y. So then you simplify by dividing 20 and 2 to get 10 and keep your square root of 3. Now our x is the long side, so we take our short side and then we have to multiply by the square root of 3. Square root of 3 times the square root of 3 is the square root of 9, or 3. So it's really 10 times 3, which is 30. Number 9. Here's our 30, 60, 90 triangle. So across from there is our short side. From our short side, we can find the long side by multiplying the square root of 3, right? So we take 17 times the square root of 3, and we can find the hypotenuse by taking our 17, our short side, and multiplying by 2. 17 times 2 is 34. Number 10, we've got a mixture of triangles here. We've got a 30, 60, 90 triangle over here. We've got a 45, 45, 90 triangle over here. Okay, so the only piece of information they gave us is this 34. Can't see that very well, can you? Okay, it says 34. So that's our hypotenuse of the 30, 60, 90 triangle. That's the hypotenuse. That means the short side across from the 30. Oops, gotta change it. The short side over here is half of that. So this has to be 17. Okay. And that means this part of y is 17 times the square root of 3. All right, now we have 45, 45 degree triangle. One of our legs is 17, so that means this part of y is 17, and then our hypotenuse would be the side length times the square root of 2, which is x. Now y, we had two pieces of it, right? We had the 17 and we had 17 square root of 3. So to get y, we have to add those two pieces together. But we can't just add the 17s together and put on the square root of 3 because we have to think of them as like terms. So we're going to keep those separate. So 17 plus 17 square root of 3. And that's your answer. All right, number 11, we got a 30-degree angle here. So this is a 30, 60, 90 triangle. And then we have a 60-degree angle here. That means this other side is also a 30, 60, 90 triangle. Okay, so I'm going to start with the number that I was given in the problem, which was the 3. The 3 is the hypotenuse, and this is going to be the 30-degree angle in that triangle. So x is the short side. So to find the short side, I take the hypotenuse and divide by 2. You can keep it as a fraction, or you could write it as a decimal. Okay, so on this other half of the triangle, the 30 tells you that x is the short side. So it's 1.5 or 3 halves. Y is the long leg. So we have to take that side length and multiply by the square root of 3. Number 12. This is a square. It tells you because of the hash marks on all 3 sides. And if it's a square, our diagonal is also an angle bisector. So this is telling us that this is a 45, 45, 90 triangle. So x is 45. And y is the diagonal of the square or the hypotenuse of the 45, 45, 90 triangle. So if our side length is 13.1, to find the hypotenuse or the diagonal of the square, we take the 13.1 and we multiply by the square root of 2. All right, number 13. Each triangle is a 45, 45, 90 triangle. We're going to find the value of x and express our answer in simplest radical form. Okay, so we're starting with this 3 that they give us. 3 is the side length, so this is a 45, 45, 90 triangle. That means this side is 3. And then to find the hypotenuse, we're going to take the side length and multiply by the square root of 2. So if that is a side of the biggest triangle there, then this other leg of the big triangle is also 3 square root of 2. And to find the diagonal or the hypotenuse of the big triangle, we take the side length and we multiply by the square root of 2. Okay, so then we have square root of 2 times the square root of 2 is 2. So this is really 3 times 2, which is 6. But on our hypotenuse here, it tells us with the hash marks that it's cut in even lengths. So this is 3 and this is 3. Together they make 6. So if we go to the little triangle, 3 is the hypotenuse of our small triangle, and we need to find the side length. So we take the hypotenuse and we divide by the square root of 2, and then rationalize the denominator. So we multiply by the square root of 2 over the square root of 2, and we get 3 square root of 2 on the top. Square root of 2 times square root of 2 is 2 on the bottom, and that's our answer. If you want, you can divide 3 and 2 to get 1.5 and keep the square root of 2. So lots of steps on that one. Oh, that's the new page. Okay, the length of number 14, the length of a diagonal of a square is 24 square root of 2 millimeters. We want to find the perimeter of the square in simplest radical form. So draw a picture. There's a square, and our diagonal is 24 square root of 2. So if you remember on our warm-up, we had a square, we cut it in half. That gives us 2 45, 45, 90 triangles. So to find the side length of the square, we just take our diagonal and we divide by the square root of 2. That means our square roots of 2 cancel, and our side length is 24. But it's a square, so all the side lengths are 24, which means our perimeter is 24 times 4, which is 96. I'm going to make that better. All right, 15. The length of a hypotenuse of a 30, 60, 90 triangle is 4. We want to find the perimeter. Okay, so the length of a hypotenuse of a 30, 60, 90 triangle. So let's draw a 30, 60, 90 triangle. There's our 90. We'll say this one's 30 and this one's 60. Really doesn't matter which one you picked, but you have to put it on there for a reference for you. Okay, so the length of the hypotenuse is 4. Sorry, hypotenuse is 4. I'm going to find the perimeter. Okay, so the 30, that's our short side. So our short side is half that hypotenuse, which is 2. And then our long side is the short side times the square root of 3. So perimeter, we want to add all of these together. Now we can add the like terms, which is 2 plus 4 is 6. And we're going to keep our 2 square root of 6. And that's your answer. All right, we're going to find the value of x. So here we have a right triangle with an altitude drawn from the right angle to the hypotenuse. That means this is a geometric mean problem. Okay, for x, we're given the altitude. So geometric means it's x squared equals a times b, where a and b are the different parts of the hypotenuse. So we know b is 64. But A, we're not given that length. We are given the big length of 100. So to find that little length, we take 100 minus 64 is 36, is A. Okay, and then we solve for x. Solve for x, we cancel that square root by square rooting both sides. So we get x equals. Now a shortcut to simplify this, you don't want to multiply that number and get a big number and then make a radical or a factor tree or however you simplified your radicals. 36 is a square, so we take 6. Square root of 36 is 6. Square root of 64 is 8. So we can do them separately. And then we have x equals 6 times 8, which is 48. Okay, number 17, we have a right triangle with an altitude drawn from the right angle to the hypotenuse. So this is another geometric mean problem. The x is on a leg. So x squared equals a times b is our geometric mean, right? Since the x is a leg and not the altitude, the a is this part of the hypotenuse that's right next to the x, and the b is the total length of the hypotenuse. Okay, so we have x squared equals a is 9, and b, we have 2 pieces that we have to add up. 16 plus 9 is 25. Solve for x, we have to take the square root on both sides. And again, we don't want to multiply this and simplify that huge number. So we can see that 9 is a perfect square. The square root of 9 is 3. 25 is a perfect square. Square root of 25 is 5. So x is equal to 3 times 5, which is 15. All right, 18, determine if the set of numbers can be the side lengths of a triangle, and if so, classify the triangle as acute, right, or obtuse. Okay, so to check if it's a triangle, first we have to add the smaller two sides and make sure it's greater than the third side. So if we add 9 plus 12, we get 21, and it is greater than 14. So we're going to say yes, it is. Now to classify it, we're going to use the Pythagorean theorem. So we use the two smaller side lengths as a and b in our Pythagorean theorem. So 9 squared plus 12 squared. And we're going to compare it to the hypotenuse, c squared. Okay, 9 squared plus 12 squared is 81 plus 144. 14 squared is 256. 81 plus 144 is 225. 225 is less than 256. So if it's less than, that means it is an obtuse triangle. Okay, B, we have 6, 8, and 13, two smaller sides. We add those together and check to make sure that they're bigger than the third side length. And they are, so yes, this is a triangle. And then we'll use our smaller two sides in the Pythagorean theorem for A and B. Compare it to the c squared. 6 squared is 36. 8 squared is 64. 13 squared is 169. We add 36 and 64 to get 100. 100 is less than less than 169, which means it's also obtuse. And our last problem, the geometric mean of two numbers. Geometric means we have geometric mean formula is x squared equals a times b. So a is 4, b is 18. To solve for x, we have to take the square root of both sides. Now sometimes it's simpler just to simplify those radicals. So the square root of 4 is 2. The square root of 18 is not a perfect square, so we can simplify it. 18 is 9 times 2. 9 is a perfect square, which is the square root of 9 is 3, and we keep our square root of 2. So multiply 3 and 2, and we get 6, square root of 2. That's it. All right, if you guys get any questions on this, please ask. Make sure you take a picture of everything that you have done and turn it in so we can get a chance to retest. Hope you guys are doing well.